Hello, my name is Guy Eldridge. I'm a Principal Product Manager here at AWS. I'm very excited to talk with you about Amazon HealthLake, a new service that we are launching here at re:Invent. In today's session, we're going to cover what is Amazon HealthLake, how does it work, and where to get started. Amazon HealthLake is a fully managed HIPAA-eligible service. It allows healthcare and life science customers to aggregate all of their disparate health information from across various silos and formats into a centralized AWS data lake. Amazon HealthLake makes it easy to import your data from on-premise to AWS. You can store both your structured and your unstructured data like clinical notes and lab results. Then, using machine learning models, it'll normalize the information by tagging the key dates, medical descriptors, and events like medications, procedures, and diagnoses, appending those data transformations to your original clinical message, never changing the data you receive. And all of that data is fully indexed, so you can quickly and easily search and analyze all of your health information. Now let's take a step back and look at all of the healthcare data being created today. Over the past decade, we've observed a massive digital transformation in healthcare and life sciences, with the digitization of the healthcare record. However, today, the most widely used clinical models, for example, predicting your risk of heart disease, are built from highly available but simple features that have less than 30 data points. However, your medical record has at least 200 to 300,000 data points available for each patient, including your medical notes. Medical data is highly contextual. It arrives in different formats, such as lab results or medical claims. The data is notorious for being messy, incomplete, and inconsistent, and it's often stored in on-premise and legacy systems. The data is also sequential, and the context is very important for clinical decisions. When a lab note comes in and there's a medical image and there's other medical information coming in, they all have different contexts, so it's disparate information, but when you pull it all together, it starts to tell you that holistic clinical story. All of that data still needs to be extracted and transformed before it can be searched and analyzed. Now let me give you a few examples, the type of challenges customers are facing. It can take weeks or months to go through individual health records and manually identify and extract key clinical information. For example, diagnoses, medications, procedures. From the notes, the documents, the images, and the forms that are coming in. Extracting this data requires special tools and requires highly specialized teams, making this a heavy lift for most customers. There are examples of taking up to 3 to 8 hours for clinicians to manually extract data from just one patient or a small cohort of patients. Emerging standards like FHIR help describe the data. They help define common formats, but you still need the technology to automate and make the data usable and scalable for your workloads. None of these data operations that are used to manage patients or predict their outcomes. These are all challenges to do with data, infrastructure, and formats, and these healthcare challenges will continue to grow as the healthcare data continues to grow. You want all of this data to come together in an organized way at the point of care, while you're working with a patient or managing a population of patients. Now let's dive a bit deeper into how structuring all of your health data leads to better clinical decisions. Extracting medical data and the clinical relationships between medical terms is hard to do. It takes time, but it's super important. When a critical data point, like a lab test, is missing from a patient's record, all of the previous patient data and notes become more critical in understanding the patient's current condition. For example, there have been plenty of times when I've been at a doctor's office and I've been missing, or probably most likely forgot, my lab results. Then the clinician or the doctor has to start going through all the multiple systems, reading all of my past notes. They start searching other available data points. They're scouring vast amounts of data to piece together a story why that test was even ordered. Amazon HealthLake helps structure that data from various systems, then tags each record to keep an updated index on every patient. Amazon HealthLake will extract entities such as medication, and it'll identify relationships such as medication with dose or with route, or tests and related results. It'll also add concepts like temporality, which is really time, and that's blood pressure, for example, blood pressure taken on January 1st, and then it has a concept of negation, which is something didn't happen, like the patient is without hypertension. Now, let's take an example. If you look at the 4 sentences from the sample clinical note, the patient's a 62-year-old female with a history of type 2 diabetes. These 4 sentences contain a ton of valuable information and detail. They're just 4 sentences. If you multiply these, the number of messages coming in every day, there's a lot of valuable data that can provide you deeper insights. For example, this note shows how to identify medical conditions such as diabetes type 2 and hypertension. It also identifies abbreviations like blood pressure, which is BP, and timestamps when the blood pressure was taken, or that there was no previous history of hypertension. All of this information is automatically structured and put into a JSON object that is then appended to the original text, providing you a detailed view of this information. Here's an example on the far right of that JSON text. First, let me say that this is complex, and we've made a point of this slide to show the complexity. So you have the notes, you have the data you're extracting, and then you have the structured object. For each of the medical entities that we pull out, there'll be a unique tag where the text will also tell you where the text is in the sentence, such as begin offset, end offset, and then a confidence score to show you the transparency of us matching that medical entity in the text. Then if you look at the arrows, they point to things like date. So you can see the first arrow points to January 14th, 2019. That's pulling the data out of the text. And then it has a concept of relationship type. So it takes that date and now it's relating it to the diagnoses, which if you can see is now nested and it's type 2 diabetes. Having this level of detail and granularity improves the efficiency and throughput for a wide variety of use cases, such as medication reconciliation, revenue cycle management, and then population and health analytics. In addition, associated medical codes are also added to help identify concepts like medication and brand name, or ICD-10 codes used for billing across all the information flowing into your system. For example, if you look at metformin, metformin has different codes. There's a 1,000 milligram code, and if you look at the bottom, you can see there's a 500 milligram tablet. So these are really important that you start identifying and pulling out the right association of not only the medication, but also the text associated with it. And then if you look at the ICD-10 code, those first 3 characters, E11, that ties to type 2 diabetes. You're not going to memorize all of those codes, but what's really important is when you start doing analytics, you want those codes. You want to normalize the data so it allows you to extract and start looking across all these different subtypes of clinical data. So now that we've pulled all this data together, this enables you to access all of the information on a patient or across all of your patients. In this example, you can see that we're combining the structured clinical data on the far left with the additional extracted medical entities on the far right. And they provide you more data inputs. So combined, you have a greater view holistically of the patient and all the data coming in. Then you can start to create a complete view of your entire health information. So now you have a complete data set with all of your patient and health information organized by different attributes, such as medication, tests, procedures, labs, and diagnoses for every patient encounter or in a health data lake. One of the examples, if you look at the clinician's notes and labs, each data element, the dose, the medication, the brand name, the procedure, they've been indexed, tagged, and they're sequenced, and we're continuously building a view of the patient or a population of patients. Basically, every orange dash, if you look at the orange dashes here, shown is a point of time. Think of it like a structured file resource, data coming in, telling you a clinical story of the patient, such as the encounter, the lab test, or the test procedure. If you go back to those 4 sentences, right, that sample clinical note, each data point, such as hypertension, type 2 diabetes, metformin, the medication, has been indexed, tagged, and sequenced. You can now query and search across your entire data using these standard medical terms. You can also apply advanced analytics or predict a bunch of interesting things with new machine learning models on each patient or the entire population of patients. For example, you could look at utilization metrics, cost, since you now can extract all the ICD-10 codes and rank them for billing, or ask population health questions. Now let's dive deep into how it works. Starting on the far left, you can connect to your clinical data systems, hospital systems, clinics, doctors' offices with 3 APIs: create, update, and delete, that each support the FHIR v4 format for interoperability. All of your data will be stored in your own dedicated HealthLake data store, with built-in machine learning models to extract all the medical entities, then structure, index, and optimize that data for the 3 APIs on the far right: search, read, and export APIs. So you can now search on keywords like hypertension or that 6-character ICD-10 code across all of your normalized and indexed data, and you can integrate that with machine learning and analytics dashboards. You can also connect third-party applications. This is really important to enable providers to share patient data with other providers and provide patients unfettered access to all of their health information. All of this put together, right, is providing you a simple API-based interaction. It'll automatically scale all of your data and resources to the amount of storage you have or the number of queries you have. So you have one place to interact and manage all of your data. Now that we've gone through the fundamentals of how it works, we're going to go through step-by-step how to get started. So step 1 is going to go through creating a data store and importing your data. And step 2 will manage your create, update, and delete APIs. Step 3 will go through reading data and then searching across all of your data. And then step 4, we're going to go through creating dashboards and building machine learning models. First thing you do is you navigate to the Amazon Health page. And then in the far right-hand corner, you click on View Data Stores. And this will allow you to first create your first data store. The data store helps you index all of your information in the FHIR format so it can be easily queried. You can start by typing in the name of the data store, and then an ID is automatically generated for you. And then you can select if you want to preload test data. We're using Cynthia created test data. Cynthia is synthetic patient data that allows you to test APIs to get comfortable with the system. In addition, the data store scales up and down based on the amount of data or the number of queries that you need. Next, you're going to import your data. To import your data, you select your data store, then you navigate to an S3 bucket, you choose the IAM permission role, and then you click Import Data. These import jobs are designed to be run one at a time. Now that your data is in the system, you can start managing your data. So Amazon HealthLake supports the FHIR query operations of create, update, and delete, and they follow the standard FHIR specifications. You can query records by performing a create, update operation or adding new patients in their information like medications or allergies. As per the FHIR specification, delete data is only hidden from analysis and results. It is not deleted from the service, only versioned. You can also read, update, and delete a previously created record. In this example, we have selected a patient FHIR resource. So this is a resource that has all the patient information. And then you can enter in a resource ID, which is a uniquely created ID, and that will return the record in the resource body, which you can see below the green line. You can also search across all of your normalized data using common medical terms. When you select your FHIR resource in a list of parameters, will be auto-populated for you based on your FHIR resource you selected. So, for example, if you selected a patient FHIR resource, remember it's a FHIR resource with all the patient data, you'll see a list of search parameters that automatically pop up like name, zip code, address. And in the example that we're showing here, you can see that we've selected the document reference resource type. This is where the majority of the unstructured data is stored. If you remember back to those 4 sentences of the patient, this is where we're pulling all that data in together, and that's where you're typically going to find unstructured data. So you can now search for hypertension, and if you look at the arrow below, you can see that hypertension results, and you can see the ICD-10 code. So you have both the entity, but you also have the codes. You now have all the structured data in a FHIR format that can easily be shared with other providers. What's important to note is, remember in the beginning we said we augment, we never change your original data. We've also included all the extensions in the far right. for the structured fields. So you can see where we've added all in the extensions to track all of that data so that you can search any of the tag data. And then finally, it's exporting your data to S3. So similar to import, you select your data store, then you're going to navigate to your S3 bucket. There you select your IAM permission role and you click Export Data. This will export all the normalized data into the FHIR format from Amazon HealthLake, and then you'll have it stored there with your S3 bucket. And for everything we just covered, there's a command line interface. So I didn't go through all the details of all the different command lines, but you can find it in our developer guide, which I'll share a link at the end of the presentation. And it has examples for each of the operations we just spoke about. Now let's focus on a few examples how to create dashboards using QuickSight or build machine learning models with SageMaker. Doing these actions allow you to enable trends in your data or make predictions, but you can also share the data securely. It's truly important that providers can confidently share patient data with other providers, and third-party applications can provide patient secure access to all of their health information. So we'll talk about integrating dashboards. In this example, I'll go through adding QuickSight dashboard. So you start with the Export API from Amazon HealthLake. You can export the normalized data to an S3 bucket. Then you use Glue to crawl and build a catalog of the data for Athena. Athena is our serverless database. Athena uses the catalog to run queries as if that file was a database. QuickSight then creates a dashboard to organize and filter through all of the data. Now let's take a look at that QuickSight dashboard. This is an example of integrating QuickSight to view all of the 3,140 encounters that you have, plus all the associated medical conditions. This is a sample dashboard using a normalized data set from Amazon HealthLake. And with that, you can start to drill into the data. For example, you can click on diabetes, and then if you can see at the very bottom left of the screen, you can view the associated patients with diabetes. So you can quickly navigate through your data by just standing up a dashboard on top of Amazon HealthLake. So now we're going to talk about integrated machine learning models. Similar to QuickSight, you can export normalized data from Amazon HealthLake to S3 and then easily integrate SageMaker to your data. You can then start training on normalized data and use a Jupyter notebook to start building your predictive models, or start running your existing predictive models off of the normalized data set. For example, using Mimic Data, which is a de-identified health database developed by MIT, we built and trained two example models, one for sepsis and one for congestive heart failure, with a data scientist and a solution architect. We initially trained the models on structured medical data only. We then trained on additional data normalized by Amazon HealthLake. We found the improved model performance with normalized data. It was measured in accuracy, precision, and overall model ROC. We also found a reduction in the false negative and false positive patients for both sepsis and congestive heart failure. This example shows how we can use Amazon HealthLake normalized data to start building your own models in the real world. Now that we've taken you through how it works, here are some examples of how customers are looking at Amazon HealthLake across the population health, improving quality of care, and optimizing hospital efficiency. Kinoka Minolta Precision Medicine is building a multimodal precision medicine platform to discover new clinical insights, relationships, by having all their clinical structured and unstructured data continuously tagged and indexed so they can easily search and query the data. Orion Health, a long-term leader in health information exchange and population health, is looking for new ways to extract key clinical indicators from patients using Amazon HealthLake to help make sense of the data in a secure, compliant, and audible way. In summary, our customers are telling us they want to take advantage of all the data they have, and they want to use machine learning to help achieve that goal. With Amazon HealthLake, you can easily import all of your health data, including all of your clinical notes and lab results. It structures all of your data in the FHIR industry standards, supporting the exchange of information across multiple applications and organizations. It automatically scales your infrastructure so you can share all your data using a common set of FHIR APIs. It'll transform, tag, and index unstructured data using specialized machine learning models. And you can query and search across the individual patient record or across all of your health data. This allows you to identify trends, make predictions with analytics, machine learning capabilities such as Amazon Athena, QuickSight, and SageMaker. In short, Amazon HealthLake is a purpose-built, HIPAA-eligible service that removes the heavy lifting of organizing, indexing, and structuring patient information, and it provides you a continuous, up-to-date view of all your health information. It is also available now in preview, and you can find everything we covered today and more details on the Amazon HealthLake page. Thank you for joining the session, and we look forward to you joining our preview of Amazon HealthLake.